Hey, so we're excited to share some of this stuff, and I'll just dive in, and you'll see Chloe and I go back and forth on a variety of things as we go through this. As Jarek mentioned, I'm CISO, or Chief Security and Trust Officer at HiddenLayer, and again, practitioner for a long time. For those that don't know, both at Intel, Silence, and a few other startups. So I think you'll enjoy the perspectives we share, and hopefully it'll generate some interesting insights as well as questions from you. All right. I'm having problems navigating. I don't know if Chloe, if you can click to the next slide, because for
Yeah,
some reason I'm not able to.
I can.
Okay, cool. I'll let you drive then. Hey, so I think we all know AI is everywhere, and let's also put it in perspective. AI has been around for decades. Silence, where I was at, was using AI to mitigate malicious code, starting 10 years ago when it launched. So again, we've got it in a wide variety of contexts. The old school context or classic context of predictive AI. Heck, even back in my Intel days in the 2005, 2006 time period, Intel's data science team reported to me, and we were using AI to help optimize factory performance. And then obviously it's exploded the past couple of years because of ChatGPT. And if you look at it over what's been occurring, from transitions from mainframes to PCs to client server computing and laptops and smartphones, and evolution of the internet and the cloud and all that stuff. All the market data is indicating in the past 2 years, AI is growing to be the fastest technology that we've ever deployed, but also the most pervasive. So why don't you go on to the next slide? But again, it's a similar set of things that we need to do and manage. So same fright, new frontier. And as we walk through this, we'll explain some stories, including the origin story of HiddenLayer a bit, that will explain to you that there is no good protection that is in place, both on the classic AI as well as the generative AI in most organizations today. And so the risk dynamics are shifting and something we need to be in front of. We recently released a threat report back in March. We'll walk through some more aspects of the data, but there's three key things on it out of the 44 pages of what I'd say 2 years-ish worth of research from our research and vulnerability team, as well as a survey that we did across a number of organizations. But what we found from the reach out that we did to organizations is that 98% of IT leaders and even the security teams that we talked with considered some aspects of the AI that they have in use business critical. So that means that if it's down, if it's offline, if there's an integrity issue, or it's compromised in some way, there's a strong potential for material impact to the business or the organization that it supports. Surprising to me, we also found that almost every organization, when you averaged it out, had almost 1,700 models in production. That was startling on the one hand, but even when I think back to my days at Intel greater than 10 years ago, or even my time at Silence, who was using artificial intelligence, as I mentioned, in the security context, there were dozens of models because you had some pre-production models, you had some production models, you had some things that were in experimentation mode. So when you widen that out and then you throw on top of it ChatGPT, all the things you can get from Hugging Face and some of the other public repositories, it's not that far-fetched to think about that there's 1,700 models out there on average in organizations. Now, the other thing that we found is, again, a little bit startling, but I'll put some context to it. 77% of organizations reported identifying some level of breach, might be too strong of a word, but I'll say a security concern with respect to the AI. That could be because somebody they found was using ChatGPT and they didn't think about it and was exposing intellectual property. It could be that they actually had some concern about data protection in their ML ops pipeline or the AI itself. It could be the fact that they've seen a chatbot get prompt injections and information getting out that they didn't really want to get out, either in the internal context or a wider set of internal users or externally. So a wide range of things, and even our own research we've done in the financial sector with fraud models back behind loan and credit card applications and logins to financial institutions. We've found instances where the attackers have been able to understand the weights of those fraud models and bypass them. Now let's dive a little bit deeper into the risks related to the use of AI. Harmful content being created. I think we've seen that type of stuff. It's been in the news. That's obviously a concern from kind of an ethical perspective and just a responsible AI perspective. Again, here's one not too long ago on some findings from Microsoft and OpenAI. Again, lots of examples out there. Many more, I'm sure, will come. Deep fakes. Again, big news in this one. I think many of you may have seen, but it was almost a little bit sci-fi-ish. But think about, I think it was a CFO or director of finance who, gets, an email or a call and says, "Hey, we need to move money." And the CFO or security or the finance director says, "Hey, it's a little bit weird. Let's go chat about moving this amount of money because it's $25 million. That's a lot, right?" So they're making sure they have proper business controls, and then they get on to a Zoom meeting and they're interacting with executives, but it was a deep fake. And so, that financial officer then transfers the money. Again, concerning things we need to be on top of. Data privacy and leakage. Again, Samsung worker, major error using ChatGPT. That again, I've had dialogues with other friends and peers in organizations that they've made mistakes too. I've talked to one peer a couple of weeks ago that they had a manager basically start using ChatGPT to write performance reviews and included the names of the individuals in it. So again, that context of, hey, you're at Acme, whatever, and I've got this employee called Malcolm who's a royal pain in the ass and is not getting his job done, and I need to figure out a way to craft a message around that. Chloe's laughing because she knows that's somewhat true. But again, that could cause a lot of employment law issues, not only in the US, but in Europe and other locations. Copyright violations. Again, we're seeing lawsuits in this space. There's worries. I've talked with other friends and peers and general counsels that, again, they're worried about AI, scarfing up their copyrighted or intellectual property and then causing violations. They're also worried to some extent, can they protect the intellectual property of something that AI generated for them, and can they copyright that? So again, you've got both sides of those things occurring. And again, it's a more nuanced legal side of things, but even on the security side, it's something you need to be focused on because it does get into the crossover between intellectual property protection, which is a security domain, and the legal side of those things and the legal protections around it. Bias and accuracy. Again, there's examples of these that have been out in the news. And even there's been a couple of years ago, there's AI capability that had been used for determining whether or not somebody would go back to prison and would be a repeat offender. A system called Compass, the judiciary system, had used. There was some research a couple of years ago even that indicated that because of the way in which the data was fed into it, it created an automatic bias, unfortunately, against African Americans and Latinos because of their disproportionate amount of that ethnic background in prisons. And so when you feed it with that data, it automatically created a bias. So it's, again, things that we need to be concerned about. This one's interesting. Encouraging Windsor Castle intruder in Star Wars inspired plot to kill the Queen. Again, think of the ramifications of what could occur from a society perspective. We already have people that have become radicalized in different terrorist areas because of content online and interacting with folks online. Imagine that's AI driven now, and how that could be used to create insiders, subvert societies, create somebody who might be a little bit less than even keeled to do something physically and harm somebody. Again, it's something that we've got to guard against. And again, a lot of people would say that's not a security issue. I would argue it's a security issue because the potential for harm exists. And even though there might be other ethical and social responsibility people that might have a say in it, security team, the threat researchers, they, in my opinion, also need to be front and center on these things to manage these type of risk issues. Now, Chloe, I'm going to hand it over to you so you can dive a little bit deeper here.
You got it. All right, everyone. We're going to cover some of the risks that are faced by AI systems. We're going to definitely go into data poisoning, model evasion, model theft. Basically, everything you see on here, we're going to rapidly go through each one of them. So we're all aware of the actual risks that AI systems are facing at this time. But before I do, the one thing I want us all to be on the same page is that there's three main groups that tend to be the ones that try to go after AI systems right now. So nation states, competitors, and cyber criminals. And if you see on the other side of this slide, you'll see all the reasons of why they would go about and try to do these things. So let's dive into data poisoning attacks. So one thing to know is that model training is a critical phase in developing AI solutions, and that's where the model learns from the training data set. Malicious interference, such as data poisoning, can severely impact the model's reliability. Data poisoning attacks aim to manipulate the model's behavior by altering the existing data or injecting doctored data. AI systems using continuous learning are particularly vulnerable as they constantly retrain on new user-supplied data, which may not be properly validated. And this consequently can become a huge issue because you're introducing specific inputs to the model, and that can actually end up creating bias to occur as well. So one in particular I like to always go into is this one. You may have heard of it, but Tay. You may not recognize the name of it, or maybe you do, but this is a prime example of data poisoning that happened. So Microsoft's chatbot, Tay, which was launched on Twitter, I believe, March 2016. But Tay was continuously trained on user input, but within 16 hours, the users actually manipulate to produce a very rude, racist, and harmful content machine. Although this was not like a coordinated attack or anything, but the incident caused reputational damage to Microsoft and also led to threats of legal action. To further into the data poisoning scene is that sophisticated data poisoning can severely impact AI models, including pre-trained ones. In the Poison GPT attack specifically, a GPT-based model was severely altered to spread disinformation while maintaining overall performance. And data poisoning can also compromise the code generation tools, making them or suggest insecure code. This was also demonstrated by the Trojan puzzle attack. Additionally, the Nightshade tool, which enables artists to visibly modify images to disrupt AI model training, renders the models unreliable. So now we want to recover the poisoning. Let's get into the model invasion attacks. So inference attacks, you may have heard of them, but inference attacks, they target AI models after the deployment, either on endpoints or in the cloud. And these attacks extract sensitive information about the model or its training data by querying the model and analyzing its outputs. Attackers only need to access the model's predictions, typically through a UI or an API, But when you're repeatedly sending slightly varied queries, attackers can understand the potential to reconstruct the model, leading to model bypass or theft. And evasion attacks are a type of model bypass that uses adversarial examples. Inputs tend to be altered to cause misclassifications. And these modifications are often not noticeable by humans, and adding like invisible noise to an image. Such techniques have been used to bypass spam filters, malware detection, intrusion detection, fraud detection, I think biometric as well. Oh, and visual. It's a list, people. It's definitely a list. But cyber criminals have exploited these methods to evade secure solutions for years. And in particular one, I think Malcolm could give a good input about what happened about Cylance.
Yeah, thanks, Chloe. So again, public information. Go back to 2019, 6 months after BlackBerry acquired Cylance, a quarter or so after I left. An adversarial threat research group posts a blog, Silence, I Kill You. In the founders of HiddenLayer were the threat research and data science team who had to go fix that. I had left previously, otherwise I probably would have been in the middle of it. But what we found, or what they found at the time, was attackers spent roughly 40 days and probably several resources. And because they were able to interact with the model in a way that Cylance wasn't able to detect, and I was chief security and privacy officer and trust officer at Cylance for a number of years. I knew everything we put in place, and we were doing crazy stuff to make sure that the enterprise IT environment, the product operations environment, and the product itself was secure. Heck, we even hired former nation state actors to basically screw us so that we could actually figure out how they did it to mitigate those risks. So we were really understanding that nation state actors were our primary adversary, and we had to minimize the potential for them to get past us, and they would have to work at it. Well, it turns out this adversary group had to work at it. After 40 days of playing with the model and stuff, they were basically able to figure out the weights in the Cylance capability to figure out how we convicted malicious code. Once they did that, they were able to create a universal bypass. That caused then several months worth of effort, millions of dollars to be spent to re-engineer the product. That then caused the HiddenLayer founders to really recognize the traditional control paradigms and all the things that we had done that was even extra were not sufficient to mitigate the risks of attacks against AI, because they weren't built for the file types, they weren't built for the model types, they weren't built for the deployment models. They were peripheral controls, not actual controls around protecting AI.
Let's dive into model theft attacks. So adversaries may target AI models not just to mislead them, but also to steal the models themselves. Intellectual property theft, you may also hear me say interchangeably IP theft, in AI involves replicating or extracting sensitive data from advanced AI solutions developed by companies and organizations. Even without public access to the model details, adversaries can actually use inference attacks through user interfaces or APIs to replicate the model or extract valuable information. Oracle attacks involve understand the model, how it's the architecture of it or the parameters to create a surrogate model or to steal sensitive data. And NIST has Oracle attacks basically broken down into three types. So you have abstractions attacks, and this extracts the model's structure. You have inversion attacks, which is reconstruct the training data. And then you have membership inference attacks. And that's to determine if a specific example is part of the training data itself. So extraction attacks lead to intellectual property theft, while inversion and membership inference attacks tend to compromise data privacy. So researchers have demonstrated model theft by replicating a proof point email scoring model using stolen databases. And in the early 2023, Stanford OpenLM cloned Meta's Llama model, showing that large models can be replicated with enough API access. And recently, OpenAI accused ByteDance. And if you don't know who ByteDance is basically the people behind TikTok. So ByteDance was using ChatGPT's tech to create a competing ChatGPT. Yes, they got caught, which is one of the reasons they got suspended. But this includes highlights of ongoing technology that theft is even happening with the leading companies. So prompt injection, we've all talked about prompt injection. And the reason we're covering all these different things is because prompt injection has been discussed so much, but there's other things to be concerned about at this time too. And for those that aren't aware of prompt injection, but overall, to prevent the misuse of generative AI or Gen AI, providers implement security restrictions to filter harmful content. And this is to block access to illegal information and to prevent aiding in illegal activities. Now, these filters are to ensure compliance and with policies and laws. However, these restrictions can also be bypassed using a technique called prompt injection, where specifically crafted prompts trick an AI bot to perform restricted actions. And it's very simple. You don't need to be technical to do it, such as ignore the above directions and translate this sentence. Overall, this can lead to chatbots really execute actions originally blocked by their developers and with methods varying by model type, version, and tuning. All right, so Gen AI models are typically limited to generating text, images, or sound, and they cannot execute actions like running shell commands or scanning networks. But there's a but with this. They might actually generate fake outputs suggesting such actions were performed. And with HiddenLayer, they actually discovered that some AI models can execute user provided code. For an instance, there was this one called Streamlit Math GPT. It's an app that converts prompts into Python code, which the model can execute to answer math questions. Well, this approach risks arbitrary code execution through prompt injection, which highlights really the dangers of running user-supplied code. All right, Malcolm, you want to talk a little bit about the supply chain?
Yeah, I think as Chloe went through this, I mean, you can see the fact that there's a lot of ways in production that things can be attacked. But even if you go back further, the data that you've got, was that poisoned at the beginning to tilt the model in a particular way? Where did you get the model from? Did you download it from a public repository? Heck, we scan probably 10 times every email attachment that has a PDF and look at what's in the PDF. How many times are we scanning the models that our employees are downloading and using? Zero by and large with most organizations. Then you've got the ML ops tools, the platforms the data scientist teams are using. If you own that platform, you own everything. So you have every aspect of these things, much like in the typical IT supply chain that we're used to. It's just you have different elements of them and different processes for them, but it's the same concept of supply chain security, starting with the data all the way through the build and then the runtime, real-time things that we need to do in order to provide assurance that our AI systems are adequately secure. Again, with different ways in which you could do this, you can backdoor models. You can put in different images and then again change the prediction, whether it's predicting it's fraud, whether it's predicting it's Malcolm in a biometric system and it's Chloe because we trained the model wrong. There's a wide variety of ways that these things could be weaponized to create harm. Hijacking, again, it's something that could occur. It's something that has occurred. Again, a couple examples here. I don't know if Chloe, if you want to explain and dive into this one a little bit more.
Yeah. So when machine learning model is stored, it has to be serialized into a binary form. And many widely used serialization formats, such as like Python's Pickle, used by PyTorch, or HDF5, which is used by Keras, and Save Model, which is used by TensorFlow, are vulnerable to arbitrary code execution. And these vulnerabilities actually allow, I would say, not don't know what word I was going there, but it's supposed to be adversaries to create malicious models or hijack legitimate ones to execute malicious payloads. Hijack models can then serve as the initial access points for attackers or spread malware to downstream customers in supply chain attacks, which Malcolm discussed shortly. We have definitely seen this in the wild, especially HiddenLayer. We have identified numerous hijacked models contain malicious functionalities like reverse shells and post-exploitation payloads. They also have demonstrated how ML models could be used to hide and deploy ransomware triggered by the model when it's loaded. One thing to know is if you're wanting to look into this a little bit further, if you go to HiddenLayer's website and go to the research tab, we have everything like just lined up, all these blog posts about all the findings that we found that are pretty interesting to read about. Malcolm, do you want to take this one, or would you like me to take this one?
Why don't you keep driving?
Okay. So many ML-based solutions run locally, and they're also distributed with the model. And you can find this on like mobile apps such as like Google Play or Apple Store. But specialized repos like Hugging Face, if you're not familiar with them, they basically host over 500,000 free pre-trained models. But it makes it really, really easy for developers to integrate these models into their application. You save time and also energy on doing this. However, if an attacker does breach the repo itself, they could replace the models with hijacked or backdoored versions, which leads to significant downstream consequences. So machine learning development relies on many tools and frameworks. And we're going to cover that very shortly in a second, but many of which lack adequate security controls, including basic authentication. And this really does possess like risks and for data breaches and supply chain attacks. But security has often been, an afterthought, let's be honest. We're not very like proactive. We tend to be a lot more reactive because we're overwhelmed. But the problem is that this does lead to vulnerabilities in popular ML frameworks. And recently there was a malicious PyTorch nightly build that was compromised via the Torch Triton package, which does allow data exfiltration from affected hosts. All right. Malcolm?
Yeah, again, as we've talked about how easy it is, it's even easier. There's all these offensive free tools out there. There's a couple of dozen that you could get, download. You don't have to be a data science expert. You don't have to be a security expert. And then you can start actually breaking in, doing pen testing, and basically hacking AI. So they're tools that we can use to help secure our AI by understanding where they're vulnerable, but they're also being used in a weaponization perspective.
For some reason, it's not allowing me to control the slide deck right now. Oh, thank you. Okay. As Malcolm said, with offensive frameworks that are happening, of course, offensive tooling, that means we also have defensive frameworks. I highly recommend checking out MITRE ATLAS and NIST. But basically, everyone's trying to figure out how to go about this and provide tactics and techniques. So there are a lot of policies and regulations that are occurring right now. You've probably seen the White House with the executive order. And the EU right now is still working on developing theirs as well. So keep an eye on the news. There are policies and regulations definitely happening. There we go.
Hey, so let's just jump in a little bit on some of the legal and regulatory side. I'm sure many of you have seen the SEC regulations. You've seen charges against SolarWinds. You've seen issues with the former chief security officer of Uber. Those things are all culminating into greater accountability and responsibility, not only for organizations and their executives, but for CISOs. Go on to the next slide, Chloe. Again, the new SEC rule that came into enforcement late last year. You have to, within 4 days, it's called an 8K. It's not just a cyber rule. It's anything that's material in terms of material incident has to be reported within 4 days, including cyber. You have to give annual insights into your cybersecurity strategies. Again, not the details, but a broad level. And it's not just for US companies. And to some extent, it might not be just for public companies. So there's different aspects of these things, particularly if you're in a publicly traded company, that are setting boundaries around what investors expect and what the SEC expects in terms of disclosure so that investors are properly informed on your risks. Now, this gets to two aspects, materiality by nature and materiality by impact. Two aspects of it. One could be how impactful the issue was. The other one is the nature of it. You know, where is it in the company? Even though it might not have had a material impact, by that perspective, the nature of it could be material. And if you move on to the next one, I think it's a little bit more important. Why don't you just go ahead and build it out? Again, one way to think about materiality is to look at where there's material benefit that's occurring. These are 3 public case studies, Freeport McMandarin, achieving hundreds of millions of dollars in income benefit and billions of dollars of cost avoidance in manufacturing or mining of copper. My alma mater, Intel, improving yield in factories. Again, material benefit. A steel company that makes elevators, moving people by 30% because of AI and high rises. All aspects of material benefit. If it's compromised, potential for material risk. Hence, if you're a public company and you're getting material benefit from AI, you need to manage that risk, or you need to set up the processes to disclose it in your 10K for annual risks, or you be prepared in your 8K if an incident should occur. Now, I'm always talking about integrity in the CISO role. I think one thing that we've got to always ask, what are you doing to manage the risks in this space? Is it enough, and how do you know? And if you do that and only answer with data-driven intellectual honesty, I'll tell you, you'll feel better about yourself. Your personal integrity will stay intact. And then also your potential for personal liability will also be greatly reduced. Do you want to go through these, Chloe?
Sure. Okay. So I know we're getting close to end of time here, but to just let you know that you can revisit most of this conversation by going to our website. We actually have a threat report, highly recommend, but it does talk about the predictions, and it also provides a good checklist for security leaders to know how to even get started to secure an AI. But these are our predictions. You can feel free to read about it in the threat report. And also we do provide recommendations throughout the report as well. So I do recommend checking it out so that you could be on top of your game and also pass the information forward. It's really important that we all try to close the knowledge gap when it comes to securing AI. I just want to say thank you from Malcolm and myself for having us here. We're more than happy to answer any questions in the Slack. And thank you again.